Hello everyone, welcome to today's video. And so last time we talked about the simple concrete block machine, or the automatic concrete block machine, just the simple version. And yes, we talked about the block making section. And in today's video, we are going to talk about the conveyor belt and the pan mixer. So I'll hide this one, and let's begin right away to talk about the conveyor belt. So the concrete block machine needs a conveyor belt system because, as you see, this the hopper is about 2 meters from the ground, and this is a raised platform. So in order to transfer the materials into the hopper, we need a conveyor belt. So the function of the conveyor belt is to raise the material and pour them into the hopper. So to receive the materials from the pan mixer, then after the materials are poured on the belt, then the belt will take them and pour them into the hopper. So today let's have a look at first of all, let's have a look at the conveyor belt. So this is our conveyor belt. Let's open it. So the conveyor belt consists of course, the belt. This is the belt here. Then we also have a motor. This is our motor here. This is a reduced motor, the ones with the gears in it. So it has a gear so that it can provide more torque, enough to pull this belt. So besides the gears in the motor, we also have a chain system here that is used to lower the speed and increase torque. So that's the function of this. That's why you see we have a small gear here, then a larger one on this side. So we shall use a chain here to link the two. Though I never put the details for the chain because it's gonna make my PC kinda slow. So we shall just have this and this, and I hope that you understand as I explain. So so the large one is connected to this shaft and to this, so they all move together. Let me just try to lock the rotation here. Lock rotation. So these move together. It's connected to that. Then it is all held in place using these bearings. These are pillow block bearings. They are flanged pillow block bearings. So when this rotates, it will pull the conveyor belt, and the conveyor belt is resting on the It's resting on these rollers here. You can get a detail of those rollers. Let me open for you. So these rollers, first of all, these rollers are welded on this frame. They are just welded on the frame. In some cases they may be bolted to the frame, but I think welding will be firmer or stronger, so they'll be welded to the frame. Let's open the rollers and have a look. So here we can see the rollers, and in the rollers we have, this is the roller frame. I called it the conveyor belt holder, but this is the frame for the rollers. So these are the rollers. The rollers consist of a bearing. Let me try to go in depth and I show you how this design of the rollers looks like. So the rollers, they consist of a bearing here. There is a bearing, we have a bearing here. This is the bearing, and the bearing and this nut here is just resting on the, it's just resting on this part of the bearing. So this sorry, so I was saying that the nut is resting on this bearing, the part of the bearing. So this whole thing moves the center, this central part of the bearing. When this nut is tied on and sits on this, these will all be stationary. They will be stationary, and this outer race of the bearing will be the one in motion. So let me try to push it in transparent form so that you can see how the inner parts are all designed. So you can have a look here. You see, this is our bearing here, and this nut will be resting on the inner race of the bearing, and the same as this side. So this outer covering will be moving with the outer race of the bearing. So the inner shaft is all stationary. Yes. The design is applicable, of course, and it can work. So this is how it is designed in this case. So let me see. So let me hide this. You can have a look now. This is the inner part of the bearing. So the covering just rests on this. Yes. So that's our bearing. That's our rollers. Our rollers are just like that, and they can hold the belt in position. So these rollers are actually inclined by an angle of maybe it's around 15. We can check that and see. So they are inclined to an angle of about 15. So I have to first check. Yeah, 15. At one angle of about 15 degrees. So that's the inclination for that, for the rollers. And these are just bolted on this and this. So this design, in my opinion, works. It will work and it can be practical. I added these gussets here just to make this firm in place, hold it in firm, yes, so it can be strong enough and work for a longer period of time. This is made out of 8 mm. I think this is 8 mm thick, 8 mm thick. They are quite strong enough, and this is just the let me go to the frame and show you. This is 60 by 30. This is just 8 mm thick, and yeah, this is also, this one can be around maybe 4 mm. Just because it doesn't need to be too thick to do its work. So that's it for that, for the rollers. Let's go back to the conveyor belt. So the rollers are all just positioned on top of this frame, and they're about 11 of them. About 11 of them. And these rollers are the ones that support the belt, and they make the V shape so that the materials can sit in and be transferred, you know. So that V shape is where the materials are. So for instance, the conveyor belt will be in this kind of shape, and our materials will be here. Materials will be here. So if it was flat, the materials won't be able to be transferred up. Yeah, they will pour off. But in this V shape, we can have a lot of material being taken up. Yes. So and that's the conveyor belt. This conveyor belt, it has this hooper here that receives some of the material and positions it on the belt, and the belt takes the material up, moves the materials up. So the roller here, compared to the other side, it doesn't have this. It's just a roller with two flanged bearings on the sides, as you see from here. So yes, this is our conveyor belt. I can try to turn it around and have a look. And the other thing, we have these rollers down here. So when the conveyor belt is working, this belt kind of sags. So the sagging may not be good. It will create extra tension, or it may get stuck. So in that case, we have these other kind of rollers here that just hold the belt in place, and there are only two, but we can have as more as 3 or 4. Then the motor has a covering. Our motor here is covered just to protect it from things like water and other things. So yeah, this is our conveyor belt. I think that's done for that. We can have a look at the pan mixer now. The pan mixer. So the pan mixer is 0.6 cubic meters, the volume, and the height is about 1 point something meters. I can check for that. And see. So it's 1.3 to the bucket, and overall it's 2 meters, about 2 meters overall. About 2 meters. So our mixer is just it's a pan mixer. That's how they call it, a pan mixer. And it is electric, and it uses this geared or reducer motor that is connected to the mixing arms, and the mixing arms are made of are curved in this shape. Yeah. So these curves are just they just kind of they act like they are spring in nature, so it will you can use any other design, but they are spring in nature, which I believe is very good for during the mixture. Yes, but any other kind of arms are okay. And the plates, we have them in this shape. These plates are in this shape. Let me try to open for you. So the plates are shaped in this form so that as you mix, the materials can be mixed thoroughly, because when the arms are moving about, the materials will go over this plate and fall behind. Then the other arm will come and do the mixture, and they fall over the plate, and so it kind of scoops, pours behind, which makes the mix more even, So that's why we have that kind of shape on the mixing plates. So the motor is held using this frame in yellow, and the pan mixer here we have is sitting on this frame. So the frame is of this shape, and we have put these other section, the square pipes here, just to increase stability, and we have also this just for stability as well. The exit for the pan mixture is there. It looks maybe small a bit here, but you can have it bigger. We can make it bigger than that. The locking part for the pan mixer is of this format. So you just push behind, push back. So let me show you from above. From here you can see that when you push back, it closes, pull, it opens, and the material pours. So it's the same ideology all throughout. You can just do this, and in some cases these are automated and they use maybe some kind of hydraulic system to do that part. But here you can just do it. Maybe a worker can do that, and when you open, the material pours on the conveyor belt and the other processes proceed from there. So yes, this is our pan mixer. These motors are common, but they are common. They can easily be purchased. Yeah. And yes, this is just bolted on this. I bolted on this. Another thing here, you can see that maybe there, but I don't think there will be any kind of problems with this. But as you see, this is, by the way, this frame is welded to the pan below. This is welded on this pan. It's not just sitting there. It is welded on it, and I believe this will be firm enough because combination of this and the weld here, it makes it firm enough. Yes, it will be strong enough in that position, in that case. So yes, this is our pan mixer, and that's it. These are bolted. The connectors are bolted here. The arms are bolted too. And another part I would like to show you about this is the mixing. Let me show you. Leave around the arms, leave around that. So let me try to hide for you this. So this connection, I want to show you the connection between the motor and the mixing arms. So this connection is, you hide this. The connection between the two is just, it's a square, it's a square shaft here, it's square. So it is square because we want it to stay firm, you know. So that's why it is square. It is square, just want it to stay firm enough. In some cases you might use a keyway, but I think this is better than a keyway because here you guarantee that everything is firm. And yes, a keyway means that at some point maybe wear out, but this, it's a bit stronger than a keyway. So yes, that's what I can hide, and I show you the part because we hide this and I show you what I'm trying to talk about. So instead of having a keyway, we have just this, a square shaft here. I have a square shaft, then the square shaft is connected to this, yes, and also this is square, so this will be a very strong connection. So the square shaft goes through there, and the bolt here locks the square shaft in place, the large bolt. So yes, basically that is it. That's our pan mixer, and that's how it is designed in this case. So yes, the pan mixer, that's it, and it just simply rotates and mixes, and when you pour in the mixture, you pour in the materials, pour in the sand, aggregates, you pour in the cement, maybe additives, maybe some other kinds of things you want. Then after you turn on the electric motor that then rotates and mixes the concrete. When the concrete is well mixed, we shall open the what? Then we shall just open. Then it will pour through this, through down here, and through that and into this hopper here and onto the conveyor belt. So basically this is how the system works. When you have your materials for making the concrete blocks, sand, cement, and the water, you pour them in the pan mixer. The pan mixer mixes them. Then you open this gate here. Sorry, this is fixed. So you open the gate, the mix pours here, then it is taken up the conveyor belt into the what? To the block making machine. Into the block machine hopper here. So that's how it works. Yes, this is I think this is it for today's video, and if there is anything I haven't explained more, you can maybe comment in the comment, and can look into that, give details for it. Thanks for watching. See you in the next video. I think in the next video I haven't had a plan yet for that, but I'll first look at the previous design and see what we can improve on it and make it a topic for next video. Yes, thanks for watching, and see you in the next video. Bye bye.